Hi everybody, I'm Colin and welcome to my videos on FIRST Robotics programming. This first video will just be an overview of how programming works in FIRST, and you won't need any programming experience to understand this video. However, the rest of the programming videos will take you through the process of actually writing robot code in Java. So that being said, if you don't already know Java, you won't really be able to understand what's going on in those videos. If you are interested in learning more about robotics programming, I strongly recommend you look up some Java programming tutorials on YouTube, or better yet, take the ICS3U course, which will teach you almost everything you need to know to program a robot. But let's leave the actual code for the next video and talk in general about how we program a FIRST robot. Programming is one of the last steps of making a robot, because the robot needs to be built in order for it to run the program. This means the programming team can't really start right away, with the exception of one subsystem, the drivetrain. The drivetrain can be programmed right at kickoff because it's very similar each year. For the other subsystems though, we can start writing the code as soon as a design team comes up with an idea. Even if we can't test or troubleshoot the code quite yet, we can still write the program once you know what motors, pneumatics, or sensors that subsystem will use. Once the robot's built, the programmers have time to test their code, see what's working and what isn't, and fix their program as best as they can. So, now we know how programming fits into making a robot, but how does the robot actually run our programs? In order for a program to run, we need some kind of computer. In FIRST, this computer is called the RoboRIO. More specifically, it's a microprocessor, very similar to a computer, but just on a smaller scale. I'm not going to spend too much time talking about how it's wired to the rest of the robot, which is normally the responsibility of the controls team, but I will briefly explain some of the connections, and this will help you understand what I'm talking about in later videos when we start working with those ports in the code. So on the left, we have these DIO, or direct input-output pins. These are direct because whatever signal goes in or out of these ports is directly what you'll see in the code. DIO ports use Boolean values, which means it's either true or false. So if electricity is flowing into the port, you'll see a true value, otherwise it'll be false. This is good for something like a leaf switch, also known as a micro switch, or really any kind of sensor that could only give you a true or false result. So that switch will only be pressed or not pressed, so there's only two options that switch could be telling you. On the right, we have the PWM ports, which stands for pulse width modulation, and these are probably what you'll be working with the most as a programmer. PWM ports can also only give true or false signals, but they work a little bit differently. They use pulses of electricity, and the length of these pulses will represent different values. These are where any motors and RGB lights will connect to on your robot. So in the case of motors, different lengths of pulses will mean different motor speeds, and for lights it could mean different colors or something like that. On the bottom, we have the analog in ports, which also can have many different values. However, the port for this value actually depends on the strength of an electric signal. An example sensor that could use this port would be an ultrasonic sensor, which senses distance. Just having an input as either on or off is not enough to represent a distance, so an analog connection is essential for this sensor. At the top, we have USB ports, which can connect to a camera, and an Ethernet port, which connects to a computer. So you can send your robot code over to the RoboRIO and control the robot. Alternatively, you can connect a Wi-Fi router to this port, so you can connect to the computer and the controllers wirelessly. Last but not least, we have the CAN, or CAN, port in the top left corner, which is how the RoboRIO sends signals to the pneumatics module. And that way you can control things like pistons and compressors with your code, which we'll get into later. So that's how the RoboRIO connects to the rest of the robot. So I know that was a lot of information, but there is still one more thing I want to talk about, which is how the robot program is structured. Our team writes code using a programming language called Java, and in order to do this, we use an app called VS Code, which is almost like Microsoft Word, but for programming. It can underline incorrect code and let you know when there's an error even before you run the program. So using this software, we create our program, which is organized into different files, which are called objects or classes. So here is an illustration of how the different classes in the program work together to make complete robot code. Our main robot class is at the top, which joins all the other components together. On the left, we have the IO, or input-output class, which handles the controller input and runs commands depending on which buttons are pressed on the controller. These commands then activate code from the subsystems, which will control the motors, pneumatic pistons, or whatever you have on the robot. So that's how our robot program works. And that's all for this video, but if you're interested in learning more about programming, stick around for the end of this video and I'll explain what you need to know to start programming a robot as well as what the next videos will cover. When learning Java, here is a checklist that will help you know when you're ready to start programming robots. First, you have the basics like variables, if statements, while and for loops, arrays, and methods. But there is one more topic you'll need to know before you start programming a first robot, and that is object-oriented programming. When you watch these tutorials and start working on programming a robot, you'll need to know what an object is and how to make programs where multiple objects work together. When we're programming a robot, we're going to be using many objects, so one for the drivetrain, one for each subsystem, one that handles the controllers, etc. So you'll need to feel comfortable working with object-oriented programming, understand object inheritance, and know the keywords that go along with it. Once you know what all of these mean and you feel comfortable using object-oriented programming, you can get started learning how to code a robot. In the next videos, we'll go more in-depth into how each of these classes work, and I'll take you through the process of programming our 2019 robot from start to finish. See you in the next video!